In this video, I want to explain about the LR1 canonical form. By using the LR1 canonical form, we can construct the CLR and LALR parsings. So here L means left to right scanning, R means reverse of rightmost derivation. 1, nothing but 1 token look ahead. And here all LRs are deterministic. Deterministic means we know that the rules which are suitable for the DFA also applied for the all LR1 canonical form. We will discuss how it is become a deterministic. So let us start with the one example. Here I have taken one example like this grammar. Okay, for this whatever, either it is LR0 or LR1, we had to convert this grammar into the augmented grammar. Here what do you mean by the augmented grammar? So derive the start symbol with another new symbol. So this is nothing but a augmentation. So after you complete the augmentation, then you start construction of a LR1 item set or canonical form. Let us start now. Let us start the canonical form. How we need to construct? First you need to we need to take the augmentation grammar into a one item. So now you already know that what is the use of dot, and the introduction topics about all bottom-up parsers, and for LR0 from other topics you already understand the use of dot. So dot nothing but at the right side of the production, we are starting with the first symbol and it is moves over the every symbol, finally reach at the end of the production. Then it is nothing but the entire production has been reduced to the one variable. So now initially we have taken the dot in front of the start symbol. Here see, for every start symbol the locate become dollar. There is a lot of story is there to how it is become a dollar. Whenever it is reached at the start symbol, means it is the end of parsing. The bottom completely reached the root of the tree. So root of the tree end with the dollar only. So that the locate for the start symbol is become a dollar. Though initially this step is mandatory, we have to take for start the augmentation production. The start symbol, their locate is become dollar. The next one. Now see here, dot is in front of the rules. How the rules are interpreted in the LR1 item set. Dot is in front of yes, so that we are deriving the respective closures. So what are the closures of yes? Nothing but what are the productions which are derived by the yes. The productions which are derived by the S are S derive L is equal R, S derive R. So you must be right. So dot is in front of yes, so that we have to write the closures of yes. Closures nothing but they are derived from the yes. Okay, I am taking the first one and second one. But here see, what is the locate of this S? The locate become dollar. See here, the S locate is become dollar. So that for their production also you need to write the dollar as a locate, and here also you must be take dollar as a locate. So dot is in front of the yes, so that you must be derive their respective closures. Closures nothing but which are derived productions of yes. And next you have to take their locates as a dollar only, because S locate here according to this yes, their locate is become a dollar, so that you have to put dollar as usually. The next you go to the second production. Now this is a production closure of this yes, but dot also again before of another non-terminal. Dot is before of non-terminal, so that you must be take the closures of this L. So I am taking closures of L. Okay, one production has been taken. And next this L, what is the next character after this L? Nothing but this is nothing but a locate. It seems like a follow, but follows are going to be verified in the entire grammar. What are the follows should be verified in the entire grammar, whereas a locate is going to be verified in their only specific production. Now this L in this production, dot is in front of this L, so that we need to write the closures of this L. Okay, now there are how many closures are there? Two closures are there. For this L, we derive the two closures. Then what is the look ahead? What is the look ahead after? What is the character after this L? Equal. So we must be take equal as a look aheads. Okay. For the sake of dot, we derive the two closures, and this L look. What is the next character of this L only? Equal. So that you have to write them. Now these two are called as a closures of this L only. Maybe another L maybe get the different kind of characters, but we are writing closure for this L, so that you have to write equal only. The next one, now I think so S is completed, L also completed. Let us go to the next production, and next production dot is again before of one another non-terminal or variable, so that we need to write the closures of this R. Closures of this R. How many productions are there for the R? There are one production only there, so that you have to derive. Now what is the lookup for this R? There is a dot before of this non-terminal, so that we have taken one production. But after this R lookup is become dollar. After this R, what you are getting? Dollar, so that you have to directly write here dollar. In case of any another character is there, then you have to take that character as a lookup. But here very next of the after the R, you are getting dollar only, so that you have to write the dollar here. But you know that this is the closure of yes. Okay, the next one I think so first one completed, second one completed, third one also completed. Let us go to the fourth one. Dot, after the dot, what did you see? Actually star is a terminal, it is not a non-terminal, so that no derivation, no productions are now derived for this star. So whenever there is a terminal, we cannot see the closures for them. We don't see the any kind of productions, so no need to take into the no need to consider any closures. The next one is dot, here also next production. I think so this is not which cannot derive the closures. Then now this one dot, after the dot there is a ID, nothing but it is a terminal. We don't see the terminal derivation. Terminal cannot derive the any production, so it is a terminal, it is a symbol which is a given input to the grammar. So that next this one also completed. Then let us go to this one. Here again dot, after the dot what you are getting? A non-terminal. So non-terminal, obviously we can see the some set of productions. So let us derive the productions of L now. How many productions are derived by the L? Two productions. See here, this L and this L both are different. This is a L in this production. We have to look the closest from this production only, not include this L. Now whereas coming to this L, which is different to this L, both are different. Their lookup is equal. Here this L lookup is become dollar. So you must be understand the lookup is different to the follow. Follows are verified in a entire grammar. Lookups are verified in the specific production only. Okay. Now let us come to the topic. Dot is before the capital L. So it is a non-terminal. We should derive that respect to closures. You derive them 1 and 2. See here, there are two productions are derived from there are closures of L, and their lookup is become dollar only, obviously, because we are looking into this L, not the first L. So that this L lookup is become dollar. So you have to write here dollar and dollar. Okay. See here, this is nothing but a item set which is started deriving from the star symbol. Okay. So initially we have taken a one production. Dot is in front of the star symbol, so that we derive their closures. Again dot is in front of the L and R, so that we write their respective closure. The last one is again dot is in front of the second L, so that you have to derive their productions. See here, in these two there are here two L's are there and here two L's are there. For these two production, lookup is become equal. For these two production, lookup is become dollar, so that we can say these two are different kind of lookups. And see, next what we should do, according to this LR0 1, either LR0 or LR1, they are a deterministic, so that whenever you see, I think so some other grammar, some kind of grammar will not get such kind of repeated derivations. Some kind of grammar will obviously get. In this grammar we see the L deriving two times with their closures. One closure set is having equal as a lookup, and another closure set is consisting of dollar. So whenever you see such kind of problems, you must be right in this format. You must be right in this format. Okay. So here S dash derive dot S dollar, and there is no change in second production, third closure, but here we are including, we are combining the L productions, because L derives dot star R, here also L derives the dot star R. Here look at is a assignment operator equal, and here it is a dollar, so that you have to write as a, if it L is deriving this production as a closure, then there follows no, there look at is become either equal or dollar, equal or dollar. Okay, so this is a rule. May not this kind of situation you can see in other example. Maybe in this problem it is repeated, so we should take. Okay, the next. Okay, so all LR0 and LR1 are DFA, nothing but deterministic for finite automata. It seems like the canonical set seems like a deterministic finite automata. To avoid the what do you mean the actual rule of DFA? The rule is that you should not move to the any other state more than one input. So that is a DFA. You should not move to the any other state